All right, welcome back. Day 17. Uh Feel like it's just kind of starting to become a rhythm now. So, rhythm, routine, maybe a little bit of both. Also, I don't know, I managed to make it online before like 11 p.m. So, that's a step in the right direction as well. But yeah, I am pretty much I think today main focus is, let's see if I have Visual Studio Code open. Main focus today is to try to finish up the materials from chapter 2. And again, the chapter 2 is the deployment chapter. So yesterday I got my model, or at least when I was going through the reading, I got the model um, training, but I didn't get into the actual deployment section. So that's what I want to do today. Hopefully, it shouldn't take too long. The training didn't take too long yesterday. It actually finished up on collabs, which kind of hasn't been. It's been hit or miss with how long it takes my training to run in collabs. So, how did that happen? You ever like swear you know how to copy and paste, but then somehow your copy and paste don't work nowhere near like how you thought it was going to? That'd be me all the time. Did that work? Okay. Yeah, so again, today is day 17. And I don't know, it just was like today when because I have to update, the date and everything whenever I go live. And I was like, kind of feels like it's starting to become a little bit more normal now. So I guess that's a good thing. So yeah, yesterday I was able to get through. I have to turn this music down like a little bit more. Yesterday I was able to get through the training and using training your model, and then did we do the data cleaning? I don't remember. I think we didn't necessarily have to. I didn't have anything to clean, I think, but um, I do remember I was able to run this image classifier cleaner, and that basically opened up the UI so that so this is just the example, but this is the one that was from running yesterday. So it opened up the UI so I could kind of audit the images and relabel them or delete them from the data set if needed. But again, like I said, based off of the confusion matrix yesterday, there wasn't much issues in distinguishing between the different bear types. So I didn't really have much to do. Even the one that was confused, there was nothing really wrong with the actual image itself. So yeah, I am going to pick up there. So I probably need to start the training and get that running. Um, oh, I need to figure out here. Let me write myself a note. Well, I guess it's a part of my log, right? So today I'm going to have to. Okay. Marisa, oh my God, what the heck? I don't do that no more. What you doing? I don't do that no more. Marisa redeemed "Hello World" in a random language. So you really trying to distract me right now? I see how it is. I see how it is. That's crazy. It's all good though. I'm gonna try to take a hot second to do that. But I am trying to stay focused today because I need to get my reading done. Um, Hello World in a random language. It's not fun when I have other things to do. I ain't gonna call that fun. That's called a distraction. It's called context switching. Um, I don't. Did I do Rust before? Even if I did, I don't remember doing it. How you gonna talk about his fun? How about you do Hello World, Mercer? Let's do that. How about that? There you go. Bam, wham, bam. Thank you, ma'am. When I see at least one day from you, you did some earlier. What's your GitHub username? Let me see. Come on, come on. What's that username, Mercer? I need to see that. Cause you know you still haven't even popped up in the 100 Days of Code channel. So what's your username? I'm waiting. I'll be waiting on that. But as I was saying, okay. So yeah, today I need to look at the collabs, how to export my model through collabs, and I'm pretty sure I saw that there was a way to do that. Pretty sure I saw a way to do that when we were watching the video. I already had mine set up in Kaggle, so I didn't really uh focus too heavy in that area. So I'm gonna figure that out. And then if not, I'll just um train the code on Kaggle. But I'm going to let's go back to I'll go back to the video lesson to try to find that out. So then besides this, I don't want to see no I'm getting there. I want to see your GitHub username, bro. We all on the same team over here. Come on, I'm getting there. Let me close this. This is a distraction now. Okay. Okay, so yesterday's progress was okay, I'm being real basic with my answers right now because my brain is a little scattered, but it's all good. What am I committing? Add day 17 log and update day 16. Push that. Okay. Alrighty, so yeah, I'm just trying to keep it pretty straightforward and be offline by midnight, because I say that like almost every day, and yesterday I still ended up being on here till like 3 in the morning, and I was so tired this morning. Oh my god, it was like painful. So I'm going to just try to keep it concise. And I have my log done, which is usually the first thing I care about, the main thing I want to get done. So I am gonna have to rerun a bunch of this stuff. So let's just see. Let's reconnect. And while I'm doing that, let's go back to the video. I'm still waiting on Mercer to give me that username. It's okay though. Okay, so yes, muted already. Perfect. So the full screen situation is kind of buggy. I don't know if anybody noticed that with when you're like back and forth between full screening your Chrome window and full screening like a YouTube video inside of Chrome. It's really weird. I get stuck. I get stuck in full screen all the time. Right, so they had the fast.ai model. They did a Kaggle and a collab one. So let's go, let me see. Putting your model into production, downloading your model on Kaggle. How to export and download your model on Google Colabs. All right, so he got the training, learn.export, run learn.export, and then go to the files. Okay, got it. I feel like I really know what I'm doing, y'all. It's kind of no, I really don't, but it it's pretty nice. So learn.export. After I trained the model, fine tune. Oh, there is actually, okay. So I don't even have to add that. But whenever I do that, it should show up over here. Perfecto. All right, so let's run the necessary panels. No, let me click this. Stop. Let me click it. Feel like I'm playing a freaking video game. I was playing a game earlier too. It was pretty satisfying. I need to get better with my keyboard and mouse controls. And I've also never finished the GTA 5 story. So earlier today I was well, not even earlier today, literally right before I started streaming. I was playing some missions on there. It's so funny because it's like my driving is literally atrocious. And I do have my controller like working with the game and everything, but that kind of defeats the purpose. So I am glad that it's working, but I have to try to, you know, just push myself to practice it a little bit. Y'all don't. Is anybody gonna try to steal my key? I don't know. Y'all probably will. I'm a. I gotta change my key. All right, so I don't need to run that one. But I think I do want to run this one. Wait, it's done? Those other parts are done already? Okay. I guess the data wasn't a big deal. I don't know. It's running way faster than I was expecting. Okay. Bears. Make my data loaders. And then we are not using the squish method for the data augmentation. We are going to be using, what was it? It was all it was a option called all transforms. I think that's the one. Which oh no, yeah, it was all transforms, but all transforms seemed like it was like a combination of random, resize crop, and perspective warp, I think. So I don't need this one either. Here's the data augmentation section. Ooh, yeah, this one right here. This is a different picture from the one that showed last time, but it's, you know, some kind of artificial um, perspective shifts on the same exact image. Oh, here it is. This one is going to do both. Random resize crop on the items, each item, and then batch transform. Run the all transforms on the batch. Okay, cool. So let's get the learning running. Yesterday, this was not bad, right? One training epoch for the to fit the pre-trained model to the data set. 4 epochs because that's how many I asked for training. And I guess that's what, a little over 10 minutes, 10, less than 15 minutes. So I shouldn't need, I don't know how long it took. I guess it didn't take very long to download the model. So let that training start. I do want to see the confusion matrix after that. We'll look at the losses. I doubt we'll need to clean anything, but you know, we might. So it'll depend on what the training looks like. Okay. And then after that, we're going to export our model. So wait. All right. So I'm pretty much here. I want to reread this part about the Yeah, I'm going to reread this section just because there's probably a little bit I could clarify, but um, especially when it came to whatever the heck is going on underneath the cleaning. Oh, they keep throwing me off using IDX as index. That's like that. I feel like maybe it's because I am a software engineer, and like we always use I, right? We always use I. Like always. I've never seen that before, but that doesn't mean that it doesn't exist. It's just in my mind, every time I see that IDX, it really confuses me for a hot second. All right, so I got my notes, and I'm going to midnight. Time to use the same lines of code to train our bear classifier. Yep. So we are able to take advantage of the transforms that we can do to our data. That is what allows us to get the most out of the smaller data set when it comes to training. So here, move this down here. Applying the, again, item underscore TFMS, that's item transforms, and then there's batch transforms. So the item transforms will run on each individual item, and then batch, runs on the group. So we'll get the random resized cropped images. So that means for each image, we'll randomly grab like different snippets of the overall image, and then we'll also like have different size options. Like some will look more zoomed in than others, I guess you could say. And then the aug transforms. I know the aug transforms run the perspective warp. Yeah, Yeah, and it's maybe something else, maybe another transform. And then once that's all set up, this is our, what do we call it? A data block. This is a data block. So we're defining this data block, right? Bears is a data block. Yep, bears is a data block. So setting that predefined data. Is this my data set, or is this the example? I skipped those. Those are the examples. Okay. This one is also an example. All right, so once we have our data loaders created from our data block that we defined, then we create our learner. Vision learner is pretty much the only thing I've seen so far for the computer vision API. So ResNet 18 from deep residual learning for image recognition. Oh, they even give the research paper reference. Okay, so Yeah, this is interesting to me because from what I can gather, this right here is going to be the, like I said, there's one for fine tune, there's one training epoch that is fitting the like the pre-trained model over to your data, and then the other epochs are how many you asked for. I would expect this to run first, right? Like by itself, not simultaneously. So that's interesting. Either way, we got two epochs down up here, and then we are still working on one up here. All right, so while that runs, we use classification interpretation dot from learner, and then here's our learner. And then one of the values we can, or one of the methods we could run at that point is the plot confusion matrix. So we saw the example of the confusion matrix, but in the confusion matrix, it's basically comparing the predictions to the actual results. I think that's how it is. Predictions on the x-axis, the predicted value on the x-axis, and the actual value on the y-axis. And then it makes, like a grid. So you can see the way you want the grid to look is you will have a solid diagonal, so that basically the predicted value and the actual value will be the same. So that's what's going to cause you to have a diagonal down the middle. But and then you want pretty much all the rest of the matrix to be white. But if you don't have then I guess I should say, from how they usually plot it as well, trying to think how they usually plot it as well, you want to have a, like, the direction of the diagonal should be a negative slope, right? Because if it was if it was, no, I guess if it was positive slope, then that wouldn't be totally off, but it would basically mean that the, like, most of your data is was misclassified. But yeah, so you basically want a solid, solid blocks down the middle, diagonal, and then everything else you want to be white, because it's also, kind of like color coded. But the confusion matrix is a good way to visualize where your model might be getting like confused, where there's issues in the either the predictions, or possibly even can show that there's some type of issue in the data set. So you can see which predictions were off, and then from there, that's where we kind of got into plotting the losses. And plotting the losses kind of showed us where the model was either incorrect, or it could have even been correct, but it was not very confident in the prediction. That's pretty much what falls into that area. So let's see. My examples are gone now because I'm running my own training, but one example that they gave was, from the original version of the chapter, you could see the data set included like one image that actually was like, it was two bears in one. It was a black bear and a grizzly bear side by side. And that was not, an appropriate training image. So after plotting the losses to see where, those potential issues were on which particular images, then from there we were able to use they had like this UI where you can actually oh, this is the example right here, the two bears. So then you have the cleaner, which basically allowed you to open this UI, and you can pretty much clean your data, right? You can go through and decide if you, like in this case, we could select to delete this one, or if we saw any that were labeled, we could fix the labels as well. And then down here, this is the part where I was like, okay, I feel like I don't know exactly what's happening here, but the fact that I is for IDX's index actually makes my brain process this a little bit better. So for every element in cleaner.delete, cleaner.fns, so we are, I don't know what unlink does exactly. Let's see. Just, is that literally what you would call a deletion? To delete or unlink all images. Yeah. So this is going to look at anything that needs to be deleted and run unlink on all those elements. Then this one for index and category in cleaner.change. So this will have access to the index and access to the category. And then from there, oh no, something went wrong. What happened? From there, what's shoot till? Shootil.move, shutil.move. Oh, maybe that's like some kind of shell command type of utility. Yeah, because the way that the images are labeled is based off of the path to the file, right? So if I want to change a category, I have to you change the path to that file. That's what actually changes the category in the structure of the how the images are stored. So that's kind of what I get from that. And then let me see. I'm so hungry too. I'm gonna eat after I get done today. I really don't be wanting to eat late, but I kind of have to eat late when I stream late because brain power takes up like brain power takes up calories. Why is this? What's wrong? What happened? You okay? You need my help? I'm trying to understand the issue. What's the problem? Focus the last run cell. Okay. Let's see. Is my model there? There is my model. I didn't want... I didn't give it a name, did I? Hold on. I didn't want it to be called export. Not that it matters too much, but it was supposed to be called model. Oh, I didn't give it. I didn't give it a name. That's okay. It's called export, so we got this far. So that means once it is time, we will be able to go ahead and get this up in Hugging Face. So feel good about that. All right, so yeah, let me just read the explanation for these. So we can see that amongst our black bears is an image that contains two bears, one grizzly. Oh, let me see my confusion matrix. One black bear was classified as a grizzly, and one grizzly bear was classified as a black bear this time around. Then if I look, it is prediction, actual, loss probability. Prediction, actual. So these two were not really classified properly. And then the rest of these were classified properly. However, the confidence was not high. The confidence is considered to be the probability value. So, that's kind of high though. No, I guess my bad. That's high, but that's a improper classification. This, 60, 64, and 78. So these are the main two issues that were, or the main two images that caused some type of an issue. But I mean, I don't know enough about bears to say if they are if it's the wrong classification. But I still don't have any intention to do any cleaning, so I can move forward with skipping over that part. All right, so in that case, I'm not deleting or changing anything, so I'm not going to uncomment this block right here or anything like that. Okay. So you can choose delete in the menu. When you choose delete, Image Classifier Cleaner doesn't actually do the deleting or changing of labels. It just returns the indices of the items to change. So for instance, to delete or unlink all images, we would run, yep. I'm going to do this for myself. I think I should be able to get away with this, right? Oh, that's a picture. No, it's not. There we go. Is this illegal? I'm changing it just because that's how my brain works. So visually, it'll make more sense to me. And then I guess one of the other things is that they were mentioning that when you are going to start training, instead of trying to do all the data cleaning first, actually try to train your model first, so that way you can see where any of these potential issues are. So technically this would be our first run through. But we saw, there wasn't too many issues in this particular data set that I have. So in this case, I'll move forward with my model, but I would, if I was to delete or recategorize anything, then I would actually rerun the training before I moved on to deployment. Now that we have trained our model, let's deploy it. Yay. Okay. So we have done this already, but it's just digging a little bit deeper. So turning our model into an online application. We're using Gradio and we're deploying to Hugging Face spaces. We're now going to look at what it takes to turn this model into a working online application. We will just go as far as creating a basic working prototype. We do not have the scope in this book to teach you all the details of web app development generally. Yeah, so see, like that's something that I thought about, like, oh, maybe that's something that I can, write a blog about or make a video about, since I have experience in web app development, right? So taking what we know about the deployment process and then taking advantage of the fact that we have the API access to our model once it's deployed in spaces with Gradio, and building out the application from there. So as I get a little bit, once I finish at least one of the examples, and actually get it, deployed into some type of little web app, then I'll write up something about that. So we want to be able to use our model for inference. So that's where the export method comes in. So I did run learn.export already, as you can see with my check mark, and my model got exported right here. It's called export.pickle or .pkl by default, but I could have given it a name if I had actually passed a string to the export method, but I didn't. It's all good. All in all, it's going to have the same effect. So let's see. I'm going to download it. Yeah, so it's going to take a second. I'm going to download that just so that I can keep moving on with that example. Once you got the model you're happy with, you need to save it so you can copy it over to the server. Model consists of two parts, the architecture and the train parameters. Easiest way to save the model is save both of these, because that way when you load a model, you can be sure that you have the matching architecture and parameters. So we use export to save both parts. So I'll say the learn.export saves an export.pkl file containing the model architecture and the train parameters. Is that how you spell? And the trained parameters. Okay. This method even saves a definition of how to create your data loaders. This is important because otherwise you would have to redefine how to transform your data in order to use your model in production. Fast.ai automatically uses your validation set data loader for inference. So your data augmentation will not be applied, which is generally what you want when you call export, fast.ai will save a file called export. Then you can check that the file exists. So we're checking for a .pkl file on our path. No, you'll need this file wherever you deploy your app to. For now, let's try to create a simple app within our notebook. When we use a model for getting predictions instead of training, we call it inference. But yeah, I think for the most part, I have been consistently using that terminology, inference, right? So when we used Gradio before, we just created a little bit interface that allowed us to try to classify an image based off of the model that we trained, and that's called making an inference. We can use load learner in order to create our inference learner. So let's do that. Okay. And I should have done something similar in the deployment. Let's see. Let me see if I can open up my Hugging Face space. All right. No. Go to my page. YSA I know how no models. Okay. Files. And then here's our app.py. So see, we called learn loader, but in this case, the file is called model.pkl. That's how it was exported, and that's how it was added to the project. So there is the model file there. So I'll go back and keep this. Okay, then we're able to assign the prediction. Probabilities. So learn.predict returns 3 values. All right, to create our, yep, okay. So when we're doing inferences, we're generally just getting predictions from one image at a time. To do this, pass a file name to predict. So images, there's a grizzly bear image already in here. Can I see what it looks like? This is the grizzly bear. So let's see what happens with our inference this time. It returns three things: the predicted category in the same format you originally provided. So the category was passed back as a string, the index of the predicted category, and the probabilities of each category. The last two are based on the order of the categories in the vocab of the data loaders. That is the stored list of all possible categories. At inference time, you can access the data loaders as an attribute. So I can basically see the actual list, so I know I can see which index corresponds to each category. So tensor 1 for grizzly, because this is the index, right? Yep, predicted value, the index, and then the probability. So these are, oops, I don't want to do that. I hate when that happens. And close that. These are the probabilities for index 1, which is which is black bear. This one is the probability of grizzly, and this is the probability of teddy bear based off the model that was trained. It was pretty certain that it's a grizzly bear, like exactly one, pretty much. But these are like very, very, very small values. Like these are essentially 0, but you know, at the same time, they're not exactly 0. Super, super low though. 3.54 times 10 to the negative 6. All right. So let me make sure I know. Load learner. No, inference.predict. All right, so we got the returns, the predicted category, then the index of the predicted category, and then the probabilities of each category. Okay, but then it returns those three values, which, shoot, in this case, right? So the first value, the prediction, the second value, the index, third value, all the probabilities. But then when we call classify image in this case, we only return it's like we only use the probabilities. Well, we do use the categories actually. I take that back. Oh, you know what? Let me see, because I think that's how the UI works in this case, or the interface. When we run, yeah, it doesn't, oh, it does show the value, but how does it determine that one? The label. It's just the main thing I'm trying to see more clearly is if classify image is only looking at or returning a combination of the categories and the probabilities, I want to see Gradio outputs. Let's look at, does the Gradio outputs actually choose a label based off of that? Or maybe it's something I'm not seeing. Oh my gosh, this is loading slow. Okay, there we go. Right, so see the classifier, image classifier in this case is similar. It's just returning the probabilities of each label. So something about something about the Gradio interface and how it's defined is determining which label to show. Outputs: a single Gradio component or list of Gradio components. Components can either be passed as instantiated objects or referred to by their string shortcuts. The number of output components should match the number of values returned by the function. The number of output components. If set to none, then only the input components will be displayed. It's still not giving me exactly the answer I'm looking for, but maybe they will explain it a little bit more. So I'm gonna keep going until I'll keep going until either I figure out that they're not going to tell me explain that part, or until they do explain that part. This has returned. Yeah, so predict actually returns those 3 values. And then the indices, anything index related, is based off how your data loader is set up. Okay, we can see here that if we index into the vocab, that matches up. Also note that if we index into the list of probabilities, we see a nearly 1 probability that is a grizzly. We know how to make predictions from our save model, so we have everything we need to start building our app. We can do it directly here. Okay, to use our model, we can simply treat the predict method as a regular function. So create an app from the model using any framework and techniques that we have available to us. So since we're doing this inside of the notebook, they're going to skip over the web app version and use IPython widgets, and voila. So IPython widgets are GUI components that bring together JavaScript and Python functionality in a web browser and can be created and used within a notebook. The image cleaner we saw earlier is entirely written with IPython widgets. So then, in order to avoid having to run Jupyter, for anyone that wants to use this, we use Voila. It's a system for making applications consisting of IPython widgets available to end users without having them use Jupyter at all. Voila is taking advantage of the fact that the notebook is already is a kind of web application. Essentially, it helps us automatically convert the complex web application we implicitly made into a simpler, easier to deploy version. And it'll look like a normal web app rather than a notebook. We still have the advantage of developing in a notebook, so we can build our GUI with IPython widgets. So make a file upload button, which is going to be here. This white one is the example, that's the image, but this the black one is the actual one that was just created. And then we grab an image, Simple namespace. Wait, what does it say? Attribute based namespace. Oh, we can't actually click the button, so this is going to serve as uploading. And then wait, so let me run that. Is that the same? That's not the picture we have, is it? No, we have a different one. We can use an output widget to display it. Right. So these are examples, but that's the proper image for what I have in my directory. Then we can get our predictions that way. So we'll still run the predict method, and we are assigning, this is passing back 3 values, so we're assigning those respectively. So first value will be the prediction, then index and the probability matrix, I guess you could say, probability array. Okay, use a label to display them. So here's our formatted string prediction, and then the prediction value is assigned there. Then for the probability, it grabs it uses the index of the prediction value and grabs that from the probability list. And format to 4 decimal places. We need a button to do the classification. It looks exactly like the upload. So that's like, you know, the button that actually says, here, do something. And then how do we tie the event to, oh yeah, event handler. Okay. On click classify, change. So we're setting the image. What's out PL? The only thing I don't like is that sometimes the output widget. Okay. One thing that I think can be helpful a lot if you're doing like tutorials or books or whatever and they have code snippets, is make if you do abbreviate your variables, make the abbreviations a little bit as obvious as you can, because like, okay, I can understand that's label and that's prediction just based off the context, but a few of these other ones do kind of throw me off, like out PL. But anyways, this wraps all that code in a function that we can use, basically our event handler function. So then we say button run dot on click. So that should be the widget, the button widget. when we click on the button widget, then we will run this function here. All right. You can test the button by pressing it, and you should see the images and predictions update automatically. Oh, okay. I need I need some bear pictures. Hold on. Black bear. I'm just gonna use numbers. Let's do the cubs because it did struggle a little bit with cubs. Actually, let's like scroll because I think that exact picture is in my data set. Oh, I might have seen this one too. Let's do this one. Save. I would like just name them like 1, 2, 3, but I already named some images like that when we did the cat. So just starting at 10. Can I get some cubs? These cubs. Save. 10, 11, 12. And then let's do some teddy bears. That must be a big bear because that thing looked full. Just scroll a little. All right, I'm just gonna save that one and let's just see. That's not how it's supposed to work. Okay, that's not exactly working the way I need it to. Probably because it's inside the notebook, maybe. Turn your notebook into a real app. So now you want me to start another notebook for this one. Okay. That's fine. So instead of continuing on here, I'm gonna just for once in like 2.5 weeks kind of wrap it up there because I do feel like I got the gist of like the training explanation. I know I have my model exported this time, so next time I don't actually need to train my model or anything like that. But what I do want to do moving forward is go ahead and maybe instead of using this example, tomorrow I'll start with, tomorrow I might just like, continue through here reading, but practically I'm going to, instead of deploying this model, I'm going to set up the tools I need to start training my Twitch streamer versus YouTuber image classifier. So with that being said, because I'm like, my stomach is rumbling and it's just a little bit after midnight. So I appreciate everybody for being here. Still waiting on Mirza to tell me her GitHub username. I feel like I should know your username on GitHub, but it's all I can't see Discord while I'm streaming right now. So I'll check in Discord later if you add your GitHub, because I don't know if I follow you on GitHub just yet. But yeah, we putting work in, y'all. We putting the work in. So I think it's paying off, and it will definitely pay off at the end of, another, what, 80 plus days, 83 days or whatever. So I'm excited, and I have a little bit of mental capacity left. So after I get done today, I'm going to work on some of the content that I want to be publishing and posting, so we can get that done. And I would love to get the Notion board crossed off of the list. So that's the main thing I'll probably end up trying to finish up this week. Yeah. True Zach Pack, thank you. Big W, big W. But yeah, I'll be back tomorrow, y'all. Well, every time I say tomorrow, it's really always technically today, but it doesn't matter. I'll be back later today, Thursday, and we will. It will be interesting because I have to source my own data. So, like they said, and this is similar to software in general, um, you can learn by seeing examples and things, but you really need that experience. And when it comes to machine learning and how, you can fine tune your training process and really, hone in on your models the way you want them to behave, it's all about experience, right? It's all about trying stuff and figuring out, you know um it's it's a there's an art to it, just as there's science to it, but there's also art to it. So that's why I'm excited about actually building examples as we go along. So we'll see. I have some ideas about how I can source my data. I could go the route of sticking with the Bing search API, but I also may consider some web scraping. Not my strong suit. Don't think I ever built a web scraper, but it's all good. So grab some images from both of those sites, or I might just literally manually source my data and create my data set. I don't need too many images. I still need a lot of images, but I don't need thousands of them. So that's good to know. So that's one thing I never had to do before. So I'm looking forward to that. Just kind of making my own data set, and then maybe possibly hosting that through Kaggle. So we'll see, because there is some, level of Kaggle, which is about creating and hosting data sets, I think. So I'll probably get an opportunity to look into that. So yeah. Is there anything interesting going on Twitch? When I tell you I am hungry, let's go raid Coding with Strangers. Yeah, let's raid Coding with Strangers, and I will see y'all tomorrow. Good night.